All right, guys, quick little intro on how we're going to do graphs. This video is going to be specific to the lab you're going to do, uh, but this will be for all labs we do through the year. It'll have the same general setup, same general idea each lab. It'll just be different data points. You don't have to type your name in. It's a digital copy. Um, so that's just there in case I do have to print these. But the title will be at the top, and then this is the Y Graph Lab. Now this is the alternative one. It's just the take-home one, but and then the units over to the left there. Introduction to Physics. All right, and then the problem is always going to be kind of like the gist of the lab. Like, what are we trying to solve for? It's not meant to be answered right now. It's gonna while you're doing the lab, you'll be answering that question. So the problem for this one is how can pi be determined through graphing? So this lab's going to walk you through how we can get the number pi, that 3.14, through a graph. And then what's going to happen is this is going to be the same process for all the labs. So if you can figure out this process, this lab specifically, then it will be the same process for all the labs we do. And then you'll just be um, just like I said, getting the data will vary. Now this first one, I am going to have you use stuff around the house. The future ones are I'm going to say they're all simulations, where you can still some of them will run the lab and then give you the data, or you'll have to run the lab and actually digitally get the data. It'll vary. Again, ask questions if you're ever stuck. The procedure, I tried to lay it out. If I don't have it laid out in blocks like this, I'll have it laid out in numbers. It's just and you're kind of following along. If you get stuck, bogged down, obviously message me. But the materials for this one, usually it'll just say computer, but this one you just need a ruler, various round objects. I would suggest various cups, different sizes. That we'll come to that in a second. Graphing application. The first thing I'm going to tell you, I would highly recommend graphical analysis for labs. If you're good with Desmos, go ahead and use Desmos. If you're good with Google Sheets, go ahead and use Google Sheets. Uh, for this lab, for these labs in general, I graphical analysis is so straightforward. It's meant to be a graphing application, not a general spreadsheet. Uh, but I am open to whatever you want to use. String or something similar that is easily bent, just something like a piece of paper, string that you can wrap around the object to get its circumference. All right, so the graphical analysis for Chromebooks. Again, I highly encourage it. It looks like it's a download. It's not downloading anything. It's just for some reason they still call it a download. It might put a little bit on your computers. The school allows it. You click that link. Here's my link here. Let me walk you through it. Um, you click that link, and then my site will pop up. It'll take you right to my site. The graphical analysis GW and Firefox are just apps that I recommend for your phones. The state has locked us out of phones, so we're not gonna do any labs with them. But they have a lot of your phones have a ton of sensors. They can sense magnetic fields, light intensity, sound intensity, pressure changes. So these are cool apps to play with, but outside of that, we won't do anything with them. Graphical analysis, all platforms, however, click on that. It's going to take you to Vernier and just hit Chrome OS. Now, if you're on a personal one, then hit the other options. And then this is graphical analysis. I would bookmark this this website, uh, and it runs off your browser. So then you don't have to go through that process every time. I won't put that link on every lab. You're gonna just do manual entry, and then you can run through the tour if you want, but here's your X column, here's your Y column. You're gonna enter your data that you get from the lab, and then once you got data in there, and then really you just type it in, you're gonna hit this button down here, and this pops up, and you're gonna do the labs will usually tell you, we might view statistics if we want like an average or something, or the max and the min. Sometimes we do that. Most likely you're going to do an apply curve fit. And then what we're looking for is a pattern. And what you should see most of the time is a linear pattern. I'm going to be honest with you. It's most likely linear. It might have a little bit of Like it might look like it's going to curve a little, but that's for the most part, it's going in the same straight line direction. That's linear. If it has a noticeable curve to it, that's quadratic. There's also inverse, so there's variations on that, but we'll play those will come up as we're doing the labs. So that's your first part. Get the graphical analysis up and running. Second part, pick 4 different round objects from around the house. Uh, Greater than half an inch, smaller than half an inch, it gets hard to measure. Uh, Objects should vary significantly in size. Don't do 4 cups that are basically the same size. Try to vary it as best you can. Measure, maybe you have a pop bottle in the fridge. Who knows what you got? Just any soup cans, that kind of thing. So it doesn't have to be a cup. I was just trying to throw out stuff you might have laying around. That's so you're going to pick those 4 objects. And then you're going to measure and record the diameter in the provided table. Now, so I put the units at the top. So we need to be in meters. And then wherever I have the purple answer, just digitally, I found it easier to mark where stuff needs to go. Sometimes it just gets lost. So pretty much anywhere where I have a purple, I shouldn't say pretty much, everywhere I have a purple answer spot, that is um, that is where you're going to put your answer. So your first object, trial 1, you're going to measure the diameter with the ruler and record it. Now, if you measure in centimeters, you got to move the decimal over to meters. If you measure in inches, then you're going to have to convert it to meters. Whatever you want to do, but it needs to be metric system. Uh, and then we're going to take yeah, so you measure the diameter. That's the first part. And then the second one, you're going to measure and record the circumference in the provided table. Don't calculate the circumference. I know you know how to calculate the circumference. That's not the point of the lab. The point of labs is to measure something. If I need you to calculate something, there will be a data column that will say calculate. If it doesn't say like this one specifically says measure the circumference. So just take a second. This is where the string comes in, or a piece of paper, something long enough that you can wrap around the object. And then you're gonna wrap it around, hold it tight, keep your fingers where the ends are, right? And unwrap it, measure its circumference with the ruler. And then you're gonna get, again, convert that to meters. Um, that is how you're gonna fill in your data table. And again, pick 4 different objects that vary in size. The questions, there's not always a question right here, but just I want to try to stress something. You need to be aware. This is where the only time where you need to be aware of sig figs. Your ruler probably good to the millimeters. So you could have up to 3, 4 sig figs. So it just depends on how accurate you want to measure. If you only want to measure accurate to 2 places, then your data table should only have 2 places, 2 numbers, right? If you want 3, I don't know that you're going to get more than 4. Well, I mean, you might have something fancy in your house that can go 4, 5, 6, but that is not expected. Just 2, 3, we're good to go. The graphing, the spreadsheet, it's just generic, says open a spreadsheet. So I am okay if you're opening, if you're not using the graphical analysis. And then for the most part, I'm gonna tell you where to put this stuff, because I don't want you getting bogged down in, does it go on the x-axis, does it go on the y-axis? Like, typically I will just tell you, unless the point of the lab is for you to try to figure that out. But in this case, I said enter the diameter into the x column, enter the circumference in the y column. So the x column's always first. This is for all spreadsheets. X is always first, and then the second column is always y. And it's going to plot your points, right? You're going to put in the number, hit enter, put in the number, hit enter. You're going to do that for your data table. You probably copy and paste it, actually. I think it copies in columns. Uh, Regardless, though, you're going to get that into graphical analysis. And then you're going to hit this right here. There's a picture with looks like 3 dots with a graph. That's your analyze button. And then it says, the app's going to draw. Now, if you're using another program like Sheets, I'm going to have to walk you through that. So if you're using other programs, I would only suggest it if you know how to do it. So like Desmos, if you know how to graph in Desmos, then go ahead. What we need, whoa, sorry, I'm getting ahead of myself. Yeah, we need, regardless of the program, you need a way to analyze the graph. But when you hit this button, the app will draw a best fit line that should match the data. So I'm going to tell you it's linear. The lab, I won't always tell you. So you got to look at the data and decide, does that look like a straight line or does it look curved? What I am telling you is it should dramatically look curved if you think it's a curve. And then it could be quadratic, inverse, exponential, like what something. Most likely though, it's linear. I would go with that and see how it fits. Take a screenshot of the graph with, once you hit that, once you hit apply curve fit, it's going to put a box. Don't get rid of that box because that box has all our information. It has the equation for the line and it has the numbers that we need. You're going to screenshot that, and then at the end here, replace my graph with your graph. So you can double click on this and replace mine. That's all written up here. I'm kind of I glossed over that. Screenshot must match the data from the lab, must be original to the lab. And then here's the part. Double click the graph image at the end, uh, and then delete mine and insert yours. Now, on that graph, the equation should be clearly visible on the graph. So you're going to record the equation there. Now, the way graphical analysis does it, and most programs do it this way, they're going to tell you the general equation. Actually, I think Sheets actually puts the numbers in, which is what I want. Graphical analysis in Desmos, I think, just lists the numbers underneath. So it's going to tell you that the line you picked, right, was y equals mx plus b. But what I need you to do is put the numbers in. You're going to say y equals, and then below somewhere on that graph, it's going to tell you what the slope is. Now, could we pick 2 points, do rise over run? Yes, but then you're doing extra work that you don't need to do because the graph does it for you. Again, ask me questions if you're not sure how to get there, but the graph does it for us. So you're going to write y equals some number times x, and then plus or minus b. Your y-intercept could be a positive or could be a negative. It just depends on how your data lines up. All right, and then that's what goes there. Record the equation with numbers, not just the equation, not y equals mx plus b. I need y equals mx plus b with the numbers in it. So the trend line equation contains the slope of the graph line. We all know that that m value is the slope. So whatever m is, that's your slope. What is the slope of this line? Units, we will discuss at a later time. On this one, pi doesn't have units. So when you do meters, when you do rise over run, meters over meters, those cancel out. So that there's in this case, we don't need to discuss units because they cancel out. But that will vary lab to lab. They usually don't cancel out. All right, so you get all that from the data, and then we're gonna jump to the conclusion, and then the conclusion says the relationship between circumference and diameter is linear, with the slope being equal to pi. So for that, not all the conclusions are going to do that for you. This is just the first intro one, but it's telling you, hey, should have been linear, and it should be around. We know pi is 3.14, so your slope should have been around 3.14. So if it's not, go back and check your measurements. But what we're always going to do is compare what we know it should be versus what we got in the lab. So in this case, that would be percent error. And we'll talk about percent error, percent difference, that kind of thing. In this case, we know pi is around 3.14, so that would be considered our theoretical. That's our accepted calculated value. Experimentally is what we got from this lab. And in this case, and it's whatever you got. Maybe it was 2.9 or maybe it was 3.2. Regardless, ideally it's around 3. If it's under 20%, you're good. You don't need to fix the lab. If it's between 20 and 30, the rubric's going to knock you down some points. If it's over 30, it's going to knock you down some more points. With the deal with labs is that you'll have 2 chances with them. So the first week, I will highlight and leave a comment, and I will say like, "Hey, something's wrong with your data. You got to recheck your numbers because the numbers are throwing this lab off." Or I'll highlight your equation line from the graph, and I'll say, yeah, this is not right. Like something, maybe you switched your axes. Try regraphing. So I'll leave you some feedback on how to fix it. Again, if it's not clear, obviously message me. But that first week, when you get it, that first week, you're just gonna just try it, see what you get. Uh, and then I will look at it and be like, hey, you need to fix this, this, and this. And then you can fix those and resubmit it the second week and get points back, is what's going to happen. The conclusion, last thing on the conclusion, it will typically ask, again, not all labs, but on average, the lab's going to ask you
a similar question that's related to the lab. So in this case, this one's just asking you, do you know how to interpret a graph? So it's asking you about like what's the slope of this graph represent and what's the y-intercept mean? A couple things. Slope is always rise over run. So if you want to know, here I'm going to do this one with you because this question is on this a version of this question is on every lab. How do I know what the slope means? You look at the units. You look on the units on the y-axis and you look at the units on the x-axis, and then you do rise over run. So if the units for this one specifically, for the y, are dollars, so I got dollars divided by tickets, number of tickets specifically. So what does the slope of this graph mean? Well, it means cost per ticket. It's the cost per ticket. That's all you got to write. You don't have to tell, you don't describe it. A lot of the times you guys want to describe it and you say, well, as the number of tickets increased, the price increased. That is true, but that's not what the slope means. I want you to specifically, unit wise, tell me what it means. So all you do, slope is rise over run. You put the units for the rise in, you put the units for the run in, and you divide them. So in this case, it'd be cost uh, per ticket. Now, what does the y-intercept mean? This is also a common question. For this specific question, the y-intercept is a cost. You just look at what's on the y-axis. Sometimes this question trips people up, but all you're looking at is what's, if it asks about the y-intercept, you're just, well, what was on the y-intercept? What was the cost in dollars specifically? So what does it mean? It's um, the cost in dollars. And it's a right at when zero tickets were bought. So it's some kind of surcharge. Specifically 1.3, right? It's a buck, $1.30 extra surcharge on a ticket. Not each ticket, just added on to your purchase. So it could be a tax, whatever. It doesn't matter what it is. It's a cost, some kind of extra cost. The 1.81 would have been the slope. So it's $1.81, right? $1.81 per ticket. And then so what's that mean? Well, it's the cost per ticket. All right, guys. Again, message me if you got questions on these labs, but they're all going to kind of follow this format for you.